Steam and condensate leaks cost buildings and industrial plants millions of dollars in lost energy, while also increasing emissions from boilers due to increased operation. They create potential safety hazards and they lower the reliability of operations. Steam leaks routinely go unnoticed or simply ignored by manufacturing and industrial facilities, and as a result, they can create unnecessarily high operating costs. Unless the direct process is affected, a failed trap could go undetected for an extended period of time. A steam trap survey with the use of thermal imagery is a non-invasive solution for determining the failure rate, thus reducing operating costs, which in turn can contribute to higher profits. A steam trap is an automatic valve that allows condensate, air, and other non-condensable gases to be discharged while holding the steam in the system. Several different types of steam trap technologies exist to accomplish this extremely critical and necessary task. When steam releases its heat energy, it reverts back to water and causes condensate. This water must be separated and removed from the system, or the system would back up with water. The removal of condensate is considered the primary function of the steam trap. Steam trap applications can be divided into three very distinct categories. One is a drip application. These are by far most common applications used for steam traps. Traps used in these applications are referred to as drip traps. Generally speaking, traps used for these applications require relatively small condensate capacities and do not normally need to discharge large amounts of air. Process trap applications refer to removing condensate and air directly from a specific heat transfer process, such as a heat exchanger. Generally speaking, traps used for this process application require large condensate handling capacity and also need to be able to discharge large amounts of air. The most common trap choices for process applications are float and thermostatic traps. Steam tracing refers to using steam to indirectly elevate the temperature of a product using jacketed pipes or tubing filled with steam. Steam traps used in these applications are referred to as tracer traps. The most common trap choice for tracing applications is the thermostatic type. Mechanical traps have a float mechanism. This rises and falls in relation to the condensate level, and it usually has a mechanical linkage attached to it that opens and closes the valve. Mechanical traps operate in direct relationship to condensate levels present in the body of the steam trap. Even though there are many different types of steam traps, they all accomplish the same goal. But when they fail and cost you money. There are many different ways a steam trap can fail. They can fail open, where the trap passes large quantities of live steam, either because the mechanism is jamming or internal parts have worn away. They can fail partially open, which means the trap passes a smaller but still significant quantity of live steam due to a valve seating face becoming worn. Or they can fail closed. Failed closed traps are traps that are found to be cold. This could be because the trap mechanism is jammed or closed due to a blockage in the pipework, or the trap could be isolated. Even if a trap is isolated, it still costs you money. The Energy Services team will conduct a system-wide steam trap survey by using thermal imagery to detect failed traps based on the heat temperatures identified upstream and downstream of the trap. Following the field portion of the survey, a comprehensive report will be compiled outlining all of the traps and their current conditions with recommendations for proper replacement components. The Energy Services team will look at the application and pipe size while focusing on the pressure that the system is currently running. Oftentimes, traps are not sized accurately for the application, which can have negative effects on both the process and the energy consumption of the trap itself. We will focus on recommending the most efficient trap for the process it is performing. The report will be focused on operational efficiency as well as the return on investment that will be yielded from the project's implementation. Regardless of the size of a facility or the number of functioning traps, a company can benefit from a STEAM survey. From all of us here at the Energy Services team, thank you very much, and we look forward to working with you.